Did you know that the familiar buzz of a bee, a sound synonymous with sun-drenched meadows and vibrant blossoms, also whispers secrets into the stillness of the night? We often picture these industrious creatures tirelessly working under the golden sun, their lives a constant flurry of activity. But what happens when dusk settles and the world transforms under the gentle gaze of the moon? There is a hidden chapter in their lives, a period of quiet contemplation and poignant journeys that often goes unseen, unheard by most. Tonight we venture into this seldom explored domain, prepare to witness their resilience, their extraordinary social structures, and the subtle, almost spiritual connection they share with the natural world. Join me as we illuminate the shadows and listen to the silent stories told by the bees under the cover of darkness. We'll explore the poignant final chapters of an old bee's life, the remarkable thermal dynamics of their hives, the unwavering dedication to their lifelong roles, the alchemical transformation of pollen, and their astonishing capacity for survival against the harshest of elements. This is The Secret Life of Bees, a nighttime adventure that reveals the depth and complexity of these vital pollinators. As the sun dips below the horizon, painting the sky in hues of orange and purple, a profound change occurs within the bee community. For the elder members of the hive, the approaching night signals a solitary sojourn. These venerable foragers, their life force gently ebbing, do not seek the familiar comfort of their sisters. Instead, they choose a different path, one that leads them to rest amongst the very flowers that have sustained them and their kin. Here, nestled deep within the petals of a fading bloom or clinging to a dew-kissed leaf, the old bee prepares for the night. It is a poignant scene, this solitary figure against the vast backdrop of the encroaching darkness, a silent testament to a life lived in service. There is an almost palpable sense of awareness, a quiet acceptance of their journey's nearing end. This is not a surrender to despair, but rather a dignified retreat, a final communion with the natural world they have so diligently served. The cool night air, which might chill a younger, more vigorous bee, seems to be a gentle embrace for these elders, a calm before the possibility of a final, peaceful rest. If fortune smiles and the first rays of the morning sun greet them, these tenacious individuals will stir once more. With what strength remains, they will resume their lifelong duties. Perhaps one last flight to gather precious pollen, or a final offering of nectar to the hive. Every movement is imbued with a sense of purpose, a final act in a grand play. This behavior, this choice to spend their final nights away from the bustling hive is not born of exclusion or rejection by the colony. It is, in its own way, an act of profound altruism. No bee, it appears, wishes to burden its sisters with its passing within the meticulously maintained confines of their home. The hive is a place of life, of ceaseless activity, of nurturing the future. To die within its walls would mean an additional task for the living, the removal of the body, a diversion of energy from the vital tasks of foraging, brood care, and hive defense. The old bees, in their quiet wisdom, seem to comprehend this implicitly. Their final act is one of consideration, ensuring that their departure does not add to the labors of the colony they have served throughout their lives. And so as darkness enfolds the land, these old bees remain scattered like tiny silent sentinels among the flowers. Bees, like all insects, are creatures of the sun, their individual bodies classified as cold-blooded, or more accurately, ectothermic. This means they do not generate their own internal body heat in the way that mammals or birds do. Their body temperature and consequently their activity levels are largely dictated by the ambient temperature of their surroundings. A lone bee caught in a sudden cold snap can quickly become immobilized, its metabolic processes slowing to a crawl. Yet step inside the bustling world of a beehive and you enter a realm that defies this individual limitation. Here, in the heart of the colony, a remarkable transformation occurs. The hive is not merely a collection of individual cold-blooded insects. It is, in essence, a warm-blooded superorganism, a collective entity that can regulate its internal temperature with astonishing precision, regardless of the weather outside. This incredible feat is achieved through a symphony of coordinated effort. Tens of thousands of bees work in unison, their tiny bodies becoming components of a living furnace. One of the primary methods of heat generation is through the rapid vibration of their powerful flight muscles. By decoupling their wings and shivering their thoraxes, bees can produce significant amounts of metabolic heat. When the temperature within the hive begins to drop, particularly in the crucial brood nest where the vulnerable larvae are developing, worker bees will cluster tightly together. Those at the core of this cluster begin to shiver, their muscular exertions radiating warmth outwards. The bees on the outer layers of the cluster act as a living insulation, shielding the core from the colder exterior and trapping the precious heat within. This winter cluster, as it's known, is a marvel of natural engineering. It can maintain a core temperature of around 30 to 35 degrees Celsius, even when the outside air plummets far below freezing. The bees constantly rotate positions, those on the colder periphery moving inwards to warm up, while those from the warmer core move outwards, ensuring that no single bee becomes overly chilled or exhausted. This transformation from individual ectothermy to collective endothermy is one of the most fascinating aspects of bee biology. Honeybees exhibit a remarkable division of labor, with specialized roles ensuring colony efficiency. From birth, worker bees follow predetermined roles. Foragers specialize in either pollen or nectar collection. Pollen foragers feed larvae. Nectar collectors fuel the colony. Specialization optimizes foraging efficiency. Each bee becomes proficient in her task. This ensures balanced nutrient intake for the hive. The common dandelion, often regarded as a humble weed, is in fact a vital early spring resource for many pollinators, including our honeybees. Its bright, cheerful yellow flowers are a beacon, offering generous quantities of both nectar and pollen at a time when other floral sources may still be scarce. The pollen produced by the dandelion is a vibrant, unmistakable golden yellow, a pure and striking color. When a foraging bee, perhaps one specialized in pollen collection as we've discussed, visits a dandelion, she meticulously gathers these golden grains. Using her legs and mouth parts, she scrapes the pollen from the flower's anthers and packs it into her pollen baskets. At this stage, the pollen retains its characteristic bright yellow hue, a tiny treasure trove of protein destined for the hive's nursery. However, a fascinating transformation occurs if this dandelion pollen comes into contact with nectar, particularly within the bee's honey crop, that internal storage sac we've referred to as her small amphora. While pollen foragers primarily pack dry pollen, nectar foragers might inadvertently collect some pollen, or a bee might consume some pollen for her own sustenance, mixing it with the nectar she's also gathering. It is within this internal vessel, this small amphora where nectar begins its journey to becoming honey, that the alchemy takes place. As the golden yellow dandelion pollen mingles with the sugary nectar, a subtle but distinct chemical interaction occurs. The enzymes present in the nectar, and indeed in the bee's own secretions added to it, begin to work their magic. The result of this mixing is a visible change in color. The once bright, sunny yellow of the pure dandelion pollen gradually deepens, transforming into a richer, warmer orange hue. This is not merely a dilution of color, but a genuine alteration. A testament to the complex chemistry at play even in this seemingly simple process of gathering food. This transformation is a beautiful, small-scale example of the intricate interactions that occur in nature. The onset of winter presents a formidable challenge to a honeybee colony. As temperatures plummet and the landscape becomes barren, the bustling activity of summer gives way to a period of intense conservation and endurance. Foraging ceases, and the colony must rely entirely on the honey stores painstakingly accumulated during the warmer months. One of the critical aspects of hive hygiene and health is the ability of bees to undertake cleansing flights. These are brief excursions, typically made on warmer winter days, during which bees fly a short distance from the hive to excrete waste. Holding waste products within their bodies for extended periods can lead to the spread of diseases within the densely populated colony. Therefore, the inability to perform cleansing flights due to prolonged severe cold can pose a significant threat to the hive's survival, yet the resilience of honeybees is nothing short of extraordinary, and there are records that push the known limits of their endurance to astonishing lengths. In one particularly remarkable instance, a honeybee colony was documented to have survived for an incredible 356 days, almost a full year, through a harsh winter without a single opportunity for its members to venture outside for cleansing. Imagine the conditions within that hive. For nearly 12 months, tens of thousands of bees were confined to their dark, enclosed world. Day after day, week after week, the cold persisted, offering no respite, no brief thaw that would permit even the quickest of flights. The internal pressure, both literally and figuratively, must have been immense. The survival of this colony under such extreme duress is a profound testament to their incredible physiological adaptations and their meticulous internal organization. This record highlights not just their ability to withstand cold, but their capacity to manage internal sanitation under the most challenging circumstances imaginable. Isn't the world of bees just incredible? From the poignant, solitary vigils of the old bees spending their last nights under the stars to the collective genius that transforms a cold-blooded assembly into a warm, thriving superorganism, their lives are a constant source of marvel. We've journeyed through their unwavering dedication to lifelong tasks, witnessed the subtle alchemy that changes dandelion gold to amber, and stood in awe of their astonishing resilience against the harshest winters. Each facet of their existence reveals a new layer of complexity and beauty. These tiny architects and tireless foragers play a role so crucial to our ecosystems, a role that often goes unappreciated until we pause to look closer. Their secret lives, especially those moments veiled by darkness or the depths of winter, are filled with stories of sacrifice, cooperation, and an indomitable will to survive. They are a testament to the intricate and often surprising solutions that nature devises, a constant reminder of the delicate balance that sustains life on our planet. The story of the bee is far from over. There is always more to learn, more to discover about these fascinating creatures and the natural world they inhabit. Stay tuned for more amazing facts about nature and its wonders. Don't forget to like, share, and subscribe so you don't miss our next journey into the wild. Until then, may you always find wonder in the buzz of a bee and the intricate beauty of the world around us.